Good morning, grade 8 learners. Welcome to another episode of Valenzuela Facebook Live Science E, where learning is fun with Sir JC GUZMAN. Before we start our discussion, make sure that you have cleaned your area of responsibility and you have prepared these things with you. Periodic table of elements, calculator, and your science module. Are you ready? Last week, we have learned how to determine the properties of subatomic particles by discussing the different models of the atom, and we have learned how to compute for the value of each subatomic particles. To determine the values of each particle, it is very important to know the atomic notation, where it includes the atomic number, mass number, and the element's name and symbol. Let me see if you can still recall how to get the value of subatomic particles using the different formulas provided last time. Start pressing the heart emoji if you are ready. Alright, first number, using your periodic table of elements, can you determine what elements has 18 protons and 18 electrons? Type down your answers on our comment section below. Time's up. The answer is argon, because the number of proton and electron is equal to the atomic number of an element. Next element. Using your periodic table, determine how many neutrons are there in an atom of oxygen. Time starts now. Time's up. The correct answer is A. For us to be able to determine the number of neutrons, we should subtract the mass number, which is 16 AMU, to the atomic number, which is 8. Last one. What is the mass number of this element, which has 11 protons and 12 neutrons? Time's up. The correct answer is 22.99 AMU for sodium, or Na11. To determine the mass number, the weight of protons and neutrons, are also known as nucleons, must be added together. Good job, learners! This morning, aside from the previous topics, we will also determine the number of subatomic particles on ions and isotopes of an atom. All atoms are made up of subatomic particles. For example, the atom of helium is made up of subatomic particles, which includes 2 protons and 2 neutrons within the nucleus and another 2 electrons surrounding the nucleus of an atom. Each atom is identified based on the number of protons it has. For example, the carbon atom, represented by the element symbol C, has 6 protons, 6 neutrons, and 6 electrons. In an isotope, the number of subatomic particles are the same except on the number of their neutrons. In carbon, there are 3 variations known, such as carbon-12, carbon-13, and carbon-14. These are the different isotopes of carbon. The most known isotope of carbon is carbon-12, which is commonly used as fuel in the form of coal,